Good evening, students. I have already sent a reminder in the group, but if your friends are not here, please inform them to join in. Okay, we'll be starting the session with few updates and then I'll be handing it over to the technical trainer. Okay, so I would want all of you to be here on time. We still have 5 more minutes. Please inform all of them to join in, please. Good evening once again. Please give your friends a reminder to join in the session. We'll be starting the session in the next 3 minutes. Right, the session will be starting with the session updates and then the technical session will begin. Meanwhile, you can send messages to your friends and inform them to join in. I hope you all must have seen the messages shared in the Telegram group. If not, just take 2 minutes, visit your Telegram group and see the updates. You can see them under the pinned messages. Take 2 minutes of time, go to your Telegram and read those pinned messages, please. Thank you. We'll be starting the session in the next 2 minutes. 5 o'clock now. I think we can begin the session with the session related updates. Maybe if we can wait for 2 more minutes, more students will be joining in the session. Right. Good evening, students. I can read your messages. Good evening. Right. Let's wait for 2 more minutes and then we can begin the session. Meanwhile, inform your internship mates to join in the session, please. Yeah, one of you just asked this question where we can get the recordings of the session. If you go to the YouTube channel of EduNet Foundation, okay, you will be able to see all the live sessions, especially the technical sessions. For AMA session, we didn't go live. Only those who have attended the AMA session on last Saturday, you know, would have gotten, like you would have got your answer. But when it comes to the technical sessions, we are doing the live as well on YouTube. So you can go through the live recording, which is available on the channel name EduNet Foundation. So regarding this offer letter, I'll give you the update. Let's wait for 1 more minute and then we can start with the session, okay? Let's wait for 1 more minute. And one more thing, one of you is saying that, ma'am, I have missed marking the attendance. No problem, the link is still open. Okay, first get yourself registered properly on the LMS, right? Without that, you won't be able to mark the attendance. So please ensure that you are using the LMS with your AICTE registered email ID. Okay, then only you'll be able to mark the attendance. The attendance link is open for all the sessions. If you missed marking it, you can still do that. But before doing it, you need to go through the pinned messages in the Telegram group where we have sent you the updates, like who are the eligible candidates, who are not eligible, like what would be the next step for those non-eligible candidates. We have sent you everything. I hope you all must have checked the PDF document which we shared of your student ID. How many of you did check that? If you can send yes in the chat. How many of you have checked that? Okay, yes, yes, yes. A lot of you are saying yes. Good. So if you didn't get a chance to check that, please go to your Telegram group, check the pinned messages. There we have sent a PDF document, and above that, I have sent you a detailed written message as well. Read them, you will get to understand like who are all selected and who are all not selected. Selected as in like if you have applied it properly through the AICT portal, then your student ID will be there in the shared PDF. If not, no worries. You can join in the next internship. Okay. You need to first apply for that properly through AICTE. And you need to have your student ID as well. So all those things. Right? Okay. And please remember you are using only your AICTE registered email ID. This we keep repeating this in all our sessions, but please ensure that you're not missing this one point. Second thing, almost all of you are asking about offer letter. In the AMA session and in the previous sessions also, we have told you clearly that offer letter is completely based on your profile updates. When I say profile updates, it should happen only on the LMS. Okay, you have the profile option in LMS, right? So you need to log into your LMS properly with the AICT registered email ID. Then you need to update your profile section with the required information, your branch, your department and all that. Okay. So once that is done, we'll be able to process. After that only we'll be able to process the offer letters. So if you ask me any specific duration, let me say maybe within the next 3 days we'll be able to circulate the offer letters, because some of the students, you're still filling it. Okay, so do log into LMS properly with your AICT registered email ID, and before that you need to check whether you're an eligible candidate or not. Right? For that, go to your Telegram, check the PDF which we shared with the student IDs. If your student ID is there, which means you are selected. If it is not there, you can go ahead and apply for the upcoming internship through the AICTE portal. Okay, so offer letters will be triggered within the next 3 days. Okay, let's say that. And email ID should be the same across all three platforms. AICT registered ID has to be used everywhere. Even if you have changed any other IDs or no problem, but still you can just check it again. And if you like, you can still create another account using MS Learn, right? So you can still do that with your AICT registered ID. And many of you are asking, ma'am, do I have to complete all those courses from the advanced? Of course, you need to complete all the courses under advanced. Okay, where is my student ID? It is there in the AICT portal. If you want more information, you can go to your Telegram group, scroll up in the pinned messages. You will be able to see those messages as well, where you can see the student ID in AICT. Okay. And if you're talking about the PDF was recently shared, like yesterday only we shared it. It is also there in the pinned messages. You can go ahead and check that. Okay. So these are few updates that we wanted to share. And also I would request the technical trainers, Rohidas and Tawfiq sir, to please share the project related details with the students. And please tell them to start working on their projects by today onwards. So these are all few things that, we just thought of sharing it with you. All the very best with your internship. Now I'm handing it over to the technical trainer. Thank you.
Thank you so much, Katika ma'am. Very good evening, students. I hope I'm audible. Just give me a yes. Am I audible? Is my voice clear?
Yes, sir. You're audible.
Yes. Right? Okay. So I think that prior updates is being given for you guys, right? So and from today's session, we're gonna have the practical implementation as well, right? So what we're gonna do? So we are running out of time. So directly we'll just land into the technical content. Okay. So I'm gonna explain what exactly we're gonna do today. Kartika ma'am, can you just give me the access of sharing the screen? Yep.
Yes, sir.
Thank you so much, ma'am. Okay. Uh, so guys, just let me know, is my screen visible? Yes, perfect. Now in today's session, we're gonna just have a understanding about machine learning. We're gonna see what are the types of machine learning. We're gonna see the regression problem statements. We're gonna see about the classification one, and then we're gonna have the practical implementation. So as we are starting up with the project part today, so I'm not gonna waste taking a lot of theoretical concept. Instead, we'll focus on to the practical implementation. So there are few prerequisites like in the previous week what we had mentioned out. So I believe that everyone have the laptops along with you, right? And you can just use multiple platforms to execute machine learning projects, to create machine learning projects, right? So I'll just give you platforms what you can just use it. One is the Visual Studio Code. We call it as VS Code. You can use that. The second option is either you can go ahead with Jupyter Notebook. the Jupyter notebook, what I'll be using in a bit. Okay. So you can either go with the Google Colab also if you are not having Jupyter notebook, which you don't want to what install in your local system. Okay. So there are bunch of platforms what you can use. Okay. And these are completely free of cost. No payment needs to be given. It's completely free and it is open source. One thing what you have to just keep in mind is that you should be connected with your internet, right? Yes. We'll see what are the things we're gonna cover it today. Okay, so this will be the learning objective. We're gonna start with the machine learning. We'll see few application about machine learning. We'll see the workflow, how exactly machine learning works. Types of machine learning. Then we'll come to the supervised learning. We'll see the types of regression, classification, unsupervised learning, and the evaluation metrics, right? So I believe that we had already a strong understanding about machine learning, right? So in previous session, we had a discussion like what is machine learning and why exactly we require machine learning and what are the uses of it, right? So I will just take a small recap again. I will not waste that time. We'll just take a couple of seconds to understand this machine learning, right? So machine learning is a subset of artificial intelligence that allows for the optimization when set up correctly. So basically, it helps us to make the prediction. Okay. How we can just make the prediction? We have to take the data, we have to clean it up, we have to analyze it. We had to do a lot of pre-processing to that. Then we'll put into one of the model here, and that model will understand the pattern, and based on the pattern what your machine has learned, it's gonna give the prediction. Instead of guessing it out, your machine will give the predictions for you. So this is how the landscape of machine learning looks like. You can see there is a concept of computer science, right? So within the computer science, we have a branch called artificial intelligence. And inside artificial intelligence, there is another branch that's nothing but your machine learning. And inside machine learning, you can see that multiple branches, how it is been split out, right? We have unsupervised, we have supervised learning, semi-supervised, we also have reinforcement learning. And the combination, again, it involves the part of deep learning. Now, this is the workflow of machine learning. First, we're going to define the problem statement. First, we have to understand the client's perspective. What exact is the requirement, right? So whenever we start with the machine learning, we have to understand the problem, what exact situation it is and what exact problem it is and what exact the client needed from us, right? So that is the problem statement. First, what we need to understand. Okay. Once we clearly understand the problem statement, once we understand each and everything, what will be the next step? We will start collecting the data and we need to start preparing the data. That will be the next procedure, which means we'll collect the data either from the survey or the person or the client who has given the problem statement. He will be giving us the data. We have to do a lot of pre-processing into that. We have to collect the data. We have to do a whole bunch of things. Then after that, we're gonna develop machine learning model, right? So after cleaning the data, after doing a lot of pre-processing, what will be the next step? We're gonna develop a model. Why exactly we require a model? Because the data, whatever we have, my machine has to understand the pattern and it has to give the prediction. So we're going to develop a model so that model can understand the pattern. Okay. And what kind of model? Again, the thing is, the person who is working on to the problem statement, he has to analyze what kind of model he can use for that problem statement and which is the best model he can just use. Okay. If we just consider machine learning, there are multiple models what we can just create. Okay. In the upcoming session, we're gonna see like how exactly we can choose the models, or in a bit like once we start the practical implementation, I'm gonna show you the basic workflow, how and like what kind of models you can be selecting it out. Then the next step is test and refine. right? So you're gonna test your model. Once you select which is the best model, you're gonna next do the thing that is nothing but the testing process, like how your model is behaving. Okay, it's not like whenever your model is giving the accuracy really good with the historical data, when the prediction is made for the real time data, which is not seen by the model, sometimes it may give some wrong assumptions, wrong outputs. So you should be very careful at this also. And you have to be sure that whatever the data you are training for the model and even for the testing, it has to be matched. Even the training accuracy has to be good and followed with the testing accuracy as well. Okay. Then deployment. The next step is nothing but the deployment, which means that whenever your model is being created, once you build your entire machine learning model, after creating, after training, after testing, it means that your model is perfectly fine and the user need to access your project. What you will be doing, you will deploy it. Deployment in the sense sending your project to the online server, publishing it. You're gonna publish your project to the online server so that the users can use your project. Then finally you're gonna manage the prediction service. You're gonna give the access, like who has the authority to access this model, who can use this project, etc. So this is how the machine learning workflow will be. Any doubt in this? Any doubts? Is it clear to everyone? Are you understanding the flow? Yes. Good. Okay. Now we'll just go with the next thing here. Now these are the few real-time case studies. Okay. If you want to build any machine learning model, you can just rely on to one of the case studies here. One is the crop recommendation. Crop recommendation in the sense you can just take the data from the agriculture or the lands or something, so that you can just recommend what kind of crops can be grown. Okay, if you have a farm or something, you can just collect the data such as what is the soil fertility rate, lot of things, temperature, precipitation, lot of things will be collected as a form of data, and based on that your model can predict what kind of crops can be grown over there. Then COVID-19 is also one of the case study. Like you can just detect the variation, like a lot of things can be taken out, like in which state there was a huge amount of what COVID polluted and what is the death rate and what is the recovery rate, etc. Apart from that, sale forecasting, you can go ahead with the forecasting about the sale, like what will be the sale from past 1 year, or based on that you can try to give the predictions out, like in upcoming 5 or 6 days this might be the sale, what we can just achieve, this kind of things. Then we can also go ahead with the fraud detection. Fraud detection, like majorly used in the banks. Okay, whether any fraudulent activities which is going on. So these are the real time case studies what you can just work on to the things. Okay, so I'm not telling that you have to work on only these few things. Okay, there are a lot of other case study problems also what you can just look at. But if you just want an entire overview, like, or a few more things where you can just get the case study problems, you can refer one of the website. The website is nothing but the Kaggle. So Kaggle is a community for the data scientist or AI engineer where you can collect the real-time data. Fine. So you can just use that website to get the data very easily. You can just work on any kind of machine learning problem statements. Now we're gonna study about the types in machine learning. Okay. So I'm gonna cover up the things very quickly because we have to line into the practical implementation as well, right? So we'll make it more simple. So basically we have three types of learning. We call it as supervised learning, unsupervised learning, and reinforcement learning. Okay. One by one, we're gonna have a understanding what is supervised learning, what is unsupervised, and the reinforcement learning here. So basically, you can see this. Supervised learning is one type of a machine learning model trained on the labeled data. Trained on the labeled data, which means you have a certain idea, basically, what you are trying to predict, right? So whenever you are given a task to build a machine learning model, you will be having a prior idea or prior knowledge. Okay. Among this data, you have to predict either what is the outcome. So that becomes your supervised learning, which means you'll be having the labeled data. You can take an example here. You can see in the chart here, there is something called label data. We have tomato, carrot, and the capsicum. And basically, you're trying to figure out the labels. So there are three labels: carrot, tomato. So it is mentioned as bell pepper, right? So based on the data, you are the person who has to detect what kind of vegetable it is, right? So if you take one single feature, okay, if you take the example, the color, right? So if you have the data called as some specific feature called as color, and if the data is something called green, okay, you'll be having some sort of idea. As a human, you can directly tell that the vegetable is nothing but the capsicum or the bell pepper, because the green color can be taken either with the capsicum or with the tomato as well, right? But tomato also, sometimes there will be a greenish color which is not at what it's not at what we tell, there is a specific term, right? I believe that you have understood. But if you take another feature, that the taste, right? uh, if you eat this specific capsicum, that might be like little spicy. There are multiple features what can be added, and finally it can come to a conclusion. Okay, so that is what your supervised learning is. Okay, in simple terms, what you can just understand is supervised learning means nothing but it's the label data. For the data what you are having, there will be a label which it will be specified, and you'll be having a prior idea what exactly you're trying to predict. Then we'll talk about unsupervised learning. So unsupervised learning means that you'll not be having the labeled data, which means you will be dealing with unlabeled data. So you'll be given raw, some random fruits or vegetables. You are not having any idea what exact uh, specific vegetable it is. So basically, what you're gonna do, you're gonna create a clusters. You're gonna create the groups for that. Okay. Now you can see that there is a specific group of what onions, brinjal, and the capsicum. So that is how the groups can be created out. Okay. In unsupervised learning, basically you don't have any sort of idea what you are trying to predict, right? So you don't have any sort of idea what you are trying to predict. Basically, you have to create the groups, which means we call it as the clusters. Clusters basically means we are nothing but creating a groups. There's another type of learning that is called as reinforcement learning. So this basically reinforcement learning, it also call it as rewards and penalties. Okay, mainly we call it as rewards and penalties. So basically we'll create an agent and we'll send the agent to the environment. Okay, and in that environment your model will learn the behavior. Based on the behavior, based on the environment, your model will learn the behavior. Okay, how? We call it as rewards and penalties. Okay, so if your model is working perfectly fine, he will be awarded with something, and if he is doing some wrong things, he'll be given some penalties. Okay, so that is how your reinforcement learning will work. Okay, any doubts still here, students? Are you getting the things? Is everything clear till here? Yes. Good. Now we'll start with the types of supervised learning. Okay, so just let me, yeah, types of supervised learning. In supervised learning, we come across two different types. Okay, one is called as regression and one is the classification. Okay, so just let me know, like, how many of you have heard the term before, like classification and regression? is. I believe a lot of people have used this specific problem statement related to regression and classification. Okay, let's try to break down this specific things. Okay, we'll just understand what is this regression and what is this classification, right? Now, we'll go with the technical definition first. Now, it is telling regression tasks involve predicting a continuous numerical value from input data. What it is telling? Whenever the term comes regression, it is telling that whenever the term is regression, you have to assume that whatever the predictions you are trying to predict, it's nothing but the continuous value or the numeric. Okay, that's nothing but your regression problem is. Okay, more precisely, we're gonna break in the next slide. Okay, and we have something called classification. Okay, so classification involves in differentiating the categories. For an example, whether a person is male or a female, right? This is classification. Your model is classifying whether a person is male or a female, girl or a boy, good or a bad, whether the person is good or bad, right? Whether a person is angry or is not angry, true or false, good or bad. Okay, these kind of things are nothing but the classification. Okay, and what about the regression? Regression is nothing but basically it deals with the continuous values or the continuous numbers. That's nothing but your regression is. We'll see the example. Now you can see that temperature. Okay, so we'll just have a discussion what can be taken for the regression and what is classification. Okay, whenever you have the problem statement related to weather forecasting, mainly you will be concentrating on the temperature, right? So in temperature, you can see that your model is predicting that it is 84 degrees Celsius. It is 84 degree. It's not telling whether it is Celsius or Fahrenheit or something. Okay, but it has given 84. Okay, so basically 84 is a number, right? This becomes your regression. Okay, you're trying to predict the temperature. Whenever you are trying to predict the temperature, it will give the numbers, continuous value. That's nothing but your regression is. And what about the classification? Classification is whether the temperature is cold or hot, right? It is classifying whether the weather is cold or hot. This is basically the classification. We have one more example. Okay, in another example, we have a similar kind of thing. What will be the house price in my town next year? Okay, so predicting the house sale price of the house. So in this problem statement, you can see that the output, whatever we are trying to predict, is nothing but the number. It is showing 208K, which means it is in the form of dollars again. Okay, 208,000, right? So that's nothing but your regression is. Okay, the same problem statement, if you're trying to make it as the classification, we can just go ahead with, is it classifying what is the house price of my house, whether it is affordable or expensive, right? So easily you can understand now. I believe that you have understood the example very well. Now easily can you classify what is regression and what is classification now? Have you understood the stuff? Just let me know how many of you have not understood so that I can explain it again. Okay. Okay, few notes are coming. Let me just make it again. I'll just take a couple of seconds and again explain it. See, whenever the term comes regression, what do you mean by regression? Regression deals with the numbers, continuous values. Okay. Whatever the model you have created, whenever your model is predicting the numbers like 84, 85, 86, see, temperature cannot be fixed, right? Now, if the temperature is 33 degrees Celsius, like after 2 hours, it may vary 33.5, 33.2, 33.1. This is nothing but the regression. What about classification? Classification, you can tell whether the weather is cold or hot. Now, it is the summer season, right? So basically, we'll tell that it is hot. It's too hot in Bangalore. It's too cold in Bangalore. Like that, we can tell. So this is nothing but the classifications. Understood? Yes. Okay. Now there are a few types of algorithms, what we gonna discuss here. Okay. In regression, these are the few algorithms what you can just use. Linear regression, multiple linear regression is there, polynomial regression, ridge regression, lasso, support vector regression, decision tree regression. Okay. And we have classification also, where we will discuss about logistic regression, naive Bayes, KNN, decision tree, support vector machine, and the random forest as well. Okay, which is not given here. These are the few clustering algorithms: k-means, mean shift, db scan, hierarchical clustering, affinity propagation. Okay, now what we're gonna do is we're gonna directly start understanding the linear regression concept here. Okay, I'm gonna tell like how the linear regression algorithm works, and next we'll land into the practical implementation. Okay. And one more thing, like students, I just wanted to know, like if we drag the session like around 10 more minutes, is it fine for you guys? Okay, just drop your comments out, because I'm not sure, like I can just wrap it up the things within 7 p.m. Okay, if may require, I can just extend. Okay, or else we'll try to close it as soon as possible as well, right? Yes. Okay, sure. This is the algorithm called as linear regression. Okay, so we have a chart here. You can see that basically the green color points, what you're seeing, those are called as data points. Okay, now linear regression help you to find the relationship between one variable, which is also called as dependent variable, on another variable, which is called as independent variables. Okay, now we have two features here. One is the experience and one is the salary. I'm gonna tell you by giving the problem statement here. Okay, now what we are trying to do here is, based on the experience, we are trying to predict what is the salary. That's nothing but your problem statement is. Whenever you are trying to predict the salary is in the form of numbers. You can see 40,000, 60,000, 80,000, 10,000, 12,000. Now, can you tell me what kind of problem statement it is, whether it is regression or classification? We are trying to predict the salary here. What kind of problem statement it is, regression or classification? Yes, it is the regression, right? Now, this experience is my independent data. It is not dependent on the salary. Salary is totally dependent on the experience. If my experience is increasing, automatically there will be an increase in the salary as well. Okay, understand one thing. As the experience is getting increased, and you can see that salary is also getting increased here, right? So that is what the relationship is being telling out here. Okay, now the linear regression tells that whenever the uh, experience is getting increased, there is a slight increase in the salary as well. And it is trying to find out the relationship between the dependent and the independent variable. Okay, I'll tell the conclusion in the practical implementation when we start up the things. Okay, but you have to think that linear regression means basically we are creating a best fit line. Can you see the line what you are seeing here? It is called as best fit line, or we can also call it as the regression line. Now you might be thinking that based on the data points, why exactly the line is being created here, right? So there are data points. The green color dot, what you are seeing, that's nothing but your data point. And there is a regression line, or we can also call it as the best fit line. Now there is a understanding here. We have created a best fit line exactly in between the data points. Why? Because if we are taking the average values upon all the average, upon taking all the data points, if we are taking the average, the error rate should be minimized. Okay, I'll tell you what is that error rate. Okay, we are trying to reduce the error here. Okay, we are trying to reduce the loss function. Now what is the loss? Now you can see that the distance from the predicted point to the actual point. Now consider this is nothing but your actual point, the green color point, and the line what it is passing is the predicted point. The distance between the actual point and the predicted point is nothing but your error rate. Now let me just make it more clear here. Let me try to annotate here so that you can understand much better. Okay. Now you can see here the distance from the actual point to the predicted point, that's nothing but your loss or the error rate. You have to reduce the error rate. So upon averaging, what is the lowest error rate you are getting, that will be considered as one of the best model. Okay. Now imagine that you are creating a best fit line somewhere here. Okay. This is just an example. Okay. Let me create a best fit line here. Okay, something like this. Now you can see that the data point is here and this is your prediction. Now you can see that there's a huge distance. This is the prediction data and this is the actual data. There is a lot of error. If you take here also, lot of error. Okay. So how you have to create a line, regression line? Your regression line should be created in such a way that upon taking average of all the data point, it should match the, or it should be less error value. That's nothing but your regression line. So you have to create a regression line similar to that specific point. If you create a regression line exactly in between, that means your model is perfectly fine. Okay. Now, okay, directly let's land to the problem statement here. Okay. Now we are taking up one of the problem statement. Okay. Now ACME Insurance Inc. It is one of the company. Okay. Now in that ACME Insurance company, what exact problem they are facing? The people are facing. Wait, let me remove this annotation here. The lines are still visible. Yep. Okay. Now ACME Insurance Inc. Now, ACME Insurance Inc. is one of the company in United States. Now, it offers affordable health insurance to thousands of customers all over the United States. As the lead data scientist at ACME, you're tasked with creating an automated system to estimate the annual medical expenditure for the new customers. So there are few information what ACME is giving. Those information are such as age, sex, which is also called as gender, BMI, children, smoking habits, and the reach. Okay. Now, based on this information, what you are supposed to do, you have to create a machine learning model where if you just randomly put the data here, if you put the age, gender, BMI, children, smoking habits, and the region, your model has to predict the medical charges for that person. If the model is predicting the medical charges, what ACME company will do, what insurance company will do, they will understand what is the expenditure of the medical expenses of that person. They can assign what is the premium insurance a person can purchase. Okay. So that is a problem statement. I believe that everyone have understood the problem statement. Yes. Yes. Let me just explain again. I'll directly land into the Jupyter notebook so that I can explain it again. Okay. I'll explain again what exactly it is. Okay. ACME Insurance Inc. This is one of the company. Okay. It offers the health insurance to thousands of customers. Okay. They offer the insurance, health insurance for the people around the United States. Now, what the company have done, the company have hired a lead data scientist and they have given a task for that data scientist. And what is the task? You have to create a automated system. Okay. When the customer is providing the data such as age, gender, then BMI, smoking habits, and which region that person is from. It has to predict what is the medical charges of that person. So by seeing that medical charges, insurance company can give the health insurance for the person, for the new customers who is coming. Okay, that is the problem statement. I believe that everyone have understood the problem statement here. Yes, you can just work on Jupyter Notebook as well. Okay. There's no restriction that you have to use VS Code or Jupyter Notebook, Google Colab. Anything is fine. Okay. Whatever, yeah, BMI stands for body mass index. I'm going to explain once I start the project. Any doubts? And before we start, I'll just put few points again. Basically, I'll be sharing the GitHub link where you can find the data set, where you can find the project also. Okay, where it becomes really easy for you guys, so that you can just, after the session, you can just work with that. Okay, I'll be sharing the GitHub link as well. Okay, in the Telegram channel as well, and in the chat box also. By end of the session, I'll be sharing it. Okay. Yeah, I'll be sharing the data set as well. No need to worry. The data set also will be shared in the GitHub link only. There is a data set link where you can download it. Okay. And coming to your project as well. Yes, you can just work with any kind of project based on your choice. Yes, you can take it from the Kaggle website also. Yes. Okay. So directly we'll just start with the problem statement. We are running out of our time. Okay. Now, the prerequisites are a couple of understanding how to use the Python programming and the libraries in the Python. Okay. So what we are trying to do is we are using the pandas library and numpy library. Basically, pandas is nothing but the panel data, mainly used for the data analysis. To analyze the huge amount of data, we'll be using the library called as pandas. Okay, if I need to load the data set, I'll be using this library. Okay, and there is another library called NumPy for numerical computing. I will be using the NumPy library. Okay, now what we are trying to do is first I'll just run the code here. You can see that code cell has been executed. Now after executing the code cell, now what I'll be doing from the pandas library, I just want to read the data here. Okay, to read the data, I'll be using the command pd.read csv. Read csv means the file is nothing but the CSV file. Okay, whatever the data I'm having, that's nothing but the CSV file. And I want to read that file. So that I'm just using PD, which means from the pandas library. I want to read the CSV file. And this is the path where my file is located. Now I'll just run the code here. And the entire thing has been stored in the variable called medical df. Now let's check the medical df here. Medical df basically is a variable where the entire data has been read and stored. Now, in this data set, you can see that we have columns such as age, gender, BMI, children, smoker, region, and the charges. Now, by seeing this data set, we can understand two things here. One is the data set is belonging to the supervised learning, right? And in the supervised learning, we are trying to predict the medical charges, which means it is the regression problem. Right? So there are two things with what we have cleared it out, right? So these are the independent values, independent data, age, gender, BMI, children, smoker, region. Now, if I just randomly provide this specific information, your model has to estimate the medical charges of that person. Okay. Now, let's start understanding and explore the data here. Now, by seeing this data, we have came to know that we have 1338 rows or records and 7 different columns, right? Now, there's another keyword called info. Medical DF is nothing but the variable, and info is another keyword here. Info basically gives the summary of the data here. Now, it is telling that the column called age is containing the integer values. Whatever the values are stored, it is the integers. You can see 19, 18, 28, 33. These are the integer values. So it is showing in 64. Then Gender. Gender is object, which means we consider it as a string value. We have female, male, female, etc. Right? Then we have BMI. BMI has the float 64. Float basically the decimal values, the value with the decimal digit, 27.9, 33.7, etc. Now this BMI stands for body mass index. Now if you are not aware like what is this BMI, mainly BMI is calculated based on the height and weight of the person. Okay, based on the height and weight of the person, the BMI is being calculated, and larger the BMI, we assume that the person is much fatter. Okay, so there is a certain range what we have to maintain our BMI as well. We have a column called children, like the person, how many kids he is having, children is having. Basically, it is the integer. Smoker, again, it is an object value. Object basically means uh, yes or no. Basically, it is the string value again. We have a column called reacher. Again, it is an object. We have a column called charges. Charges, this is the column which is showing as float 64, which means which is containing the decimal digit. And whatever the charges we are getting here, it's not the Indian rupees. Understand one thing. You, whenever you come across any kind of problem statement, first and foremost thing, you have to understand the data very well. Because the better the data set you get understand from the data, okay, the better the model will be. Which means if you understand your data very well, which means working on any kind of machine learning model, it is quite easier. Okay, so we recommend that whenever you start working on any kind of machine learning problem statement, you have to understand the data very well. Okay, is that clear? Post your chats. Yes, even EDA is very important, because EDA is the process where you can understand the data very well. So I have few steps of EDA as well. I'm going to explain in a quick time. Okay, no need to worry. Then there is another keyword called describe here. Describe basically gives the statistical analysis of the data set. Okay, so medical DF is the variable, and here we are using the describe function. See, understand one more thing. Describe is mainly used for the numerical values. Okay, now you can see that age is the number. In the age column, we have the values like integer values. BMI is the number, children is the number, and the charges are. Okay, now statistical analysis is giving the entire summary of the data here. It is telling that from the data, there is a minimum age 18. Okay, whatever the data we have collected, the minimum age is starting from 18, and the maximum age is nothing but 64 of the age column, which means in the data set, it is clearly mentioned that if we are crossing the age like more than 63, 64 or something, the premium will not be given for the health insurance. It's fair question, right? As the age increases, the chances of person getting ill or something, or getting hospitalized is more. Chances is more. So the insurance company also target the certain age group, which is from 18 to, like, it depends on company to company, right? We have the mean, which means the average. Mean is also called as the average. Then we have the 50th percentile, which is also considered as a median value. Okay. Now you can see the charges as well. You can relate the charges. Charges basically, the minimum charge is 1,121. This is the annual charges. Okay. Don't get confused here. This is the annual charges. Minimum charge is 1,121. There are few people who came who is spending only $1,121 per year. Okay. And what is the maximum? Maximum, you can see that people have spent like $63,770. Okay. And what is the average spending? Average spending is nothing but 13,270. This is the average spending what the people are spending in United States. Okay. Yes. Now, similar to that, we have the BMI column as well. In BMI, you can see that the BMI value is 15.96, right? So 15.96 basically means that the person is quite uh, thinner, which means he's too lean. Okay. So there is a certain BMI value what a person has to be matched. For an example, it's probably, I think, 22 or 23 to 26 or something. I'm not sure. You can just check the chart where you can understand the BMI. Okay. In few slides, I'll be showing. And there's a maximum BMI value which is showing 53, which means there's a person who is much fatter. He's too fat, right? Same goes with the children. There are few people who have the 5 children with them. Minimum is 0, which means few people who doesn't have the child, which means they are unmarried also, right? Those kind of EDA, you can just do it. Okay. Now we'll just start with exploratory data analysis and visualization. Okay. Where we are starting with exploring the data here mainly. So I'm using Plotly library and Matplotlib followed with the Seaborn. So these are the few libraries what we mainly use for the visualization to create the charts, graph, etc. Okay. So I'll just run this. First, we are focusing on the age column. I'll just check the statistical analysis for the age column. Like we have taken that maximum age is 64 and the minimum age is 18 again. The previous example we saw, the same thing is available here. Okay. And what we are trying to do, we are creating a histogram. And in the axis, I'm keeping the age column. For the age column, I'm creating a histogram. Okay. Let's see what exact histogram it is showing. So histogram gives the distribution of the data mainly. For the age column, it is giving the distribution. And you can see that age 18, there are 69 customers. Age 19, again 68. And as the age 20, there is a uniform distribution. You can see they are distributed like uniformly, right? So like count is 29, 28, 27, etc. It goes on. Okay. And the age up to 64 and the count is going like 22. Okay. Now there are two bins here. You can say age 18 and 19. Can you tell me like why there is a steepness here? Why there is more number of 18 and 19? Can anyone try to figure it out why exactly age 18 and 19 have more number of customers? Yeah, you can put your views. Okay. We are not telling ki like we want the exact actual answer. You can just put your points. Smoking person, not exactly. Low premium price, ill rate low. Yeah, basically eligibility starts from the 18 years. Okay. The eligibility is starting from 18 years. I'm not telling each and every insurance company start the eligibility from 18, but few companies start the eligibility from 18. You have to make sure that you understand the data very well. Okay. After all, you are creating the model. You are the person who have to be sure what exactly you're doing. Okay. Yes. Then again, we are discussing about BMI. You can see the distribution of BMI and you can see the BMI of normal range, which is from 25 to 30. Like there are 92, 90, 82, etc. And there are few people who is crossing the BMI. Like you can see the BMI is 53, uh, then again 51, etc. Now let's figure out like how the BMI should be. Okay. So it is considered as if my BMI is 18.5, it is considered as underweight. 18.5 to 25, it is normal weight. Then 25 to 30, it's overweight. We call it as 30 to 40, it is obese. And more than 40 is nothing but morbid obese or extreme obese. Okay. So how the BMI has been calculated based on the height and weight. Clear? Just give me the thumbs up if you are getting the things. Are we good to go to the next things? Okay, so few people are asking what is n bins. N bins basically number of bins, how many bins in the histogram you want to create. You can see here, there are bins, right? This is specific bin, bars. Okay, how many bins you want? That bins can be allocated. Okay. Yes. Okay. You can also verify with the medical charges as well again. Okay. So what we are trying to do is we are trying to create a histogram with the relationship with the charges, and we are keeping the smoker in the hue part, which means we are highlighting the smokers and comparing the charges. And in smoker category, we had two different kind. One is the non-smokers and one is the smoker. There are few people who had the habit of smoking, and there were few people who were not having the habit of smoking as well. Okay, we'll try to figure out that one. Okay, so you can see this is the histogram, and it is telling that the peach color, what you are trying to see is non-smokers, and blue color, the people are smokers. And by seeing this chart, we can definitely tell one specific scenario that non-smokers have less medical charges, right? By seeing the chart, you can easily understand one thing. The people who doesn't smoke, their medical charges is not that much. You can see that x-axis, the charges is in the x-axis. Okay. And you can see the blue color bins where the medical charges is going like 60,000, 63, 50,000, etc. and dollars, right? The even though the count is less for the smokers, but the medical charges is more high. And non-smokers, the people who doesn't smoke, the count is more and the medical charges is very less. This is one insight what we are trying to understand from the data, right? Yes. Let's see one more thing. Okay, the same chart, what we are trying to do is we are trying to visualize it in the Plotly library. This is from the Seaborn library, SNS, Seaborn library. And again, we are creating a chart from the Plotly library to give a 3D view, okay, which is from the Plotly library, PX. There are a lot of what EDA which has been pending out here. You can see that we are visualizing the smoker here. Okay. These are the non-smokers, and this is the count of female and the male. And these are the smoker count of the female and the male here. You can see male smokers, there are 159 people. Female smokers, there are 115 people. Simultaneously, we have non-smokers as well. The count is much closer here. Okay. Female 547 non-smokers are there, and 517 non-smoker males are available. Okay. Yes. We can also create a scatter plot. So this is called as a scatter plot. Okay. To create a scatter plot, you can just use a function called scatter, and you can pass the data set whatever you want, and you can give what column you're trying to create. So you're finding out the relationship between the age and the charges, and you're giving the color for the smoker. Okay, there are two colors here, blue and red. So red is non-smokers here. You can see red is non-smoker, blue is the smokers. You can see one simple what insight here. In this insight, easily you can understand that the people who doesn't have the habit of smoking, their medical charges is not high. See, in the y-axis, we have the charges column, right? So charges basically is nothing but like what is the medical charges annually the customer is paying. Okay. The blue color dots are quite going upwards, which means they are the smokers. Okay. So there are three clusters basically. One is the normal cluster at the bottom. One is the mid range, and one is at the top. In the top side, you can see max to max. Uh, None of the non-smokers are available. All the smokers are available. The top cluster, right? Yes. Guys, are you understanding the stuff? Post your comments in the chat box. Is it easy? Easy to understand? 100%. Yes, good. Good. Okay, so there are few questions what people are asking why exactly we need to create the charts, graph and all. See, whenever the problem statement comes, okay, whenever client gives you a problem, right? So to understand the entire data, you have to create the visualization. You have to perform the EDA. You have to explore the data. How you can explore the data? By checking the different columns, what are the values are available, what are the things are available in the data, and how it is related to each other. So if you just want to understand the data very well, you have to follow these steps. Clear? No worries. For the reference part, the GitHub link I'll be sharing in the Telegram and again in the chat box after the session. So you can just go ahead practicing this project. Okay. And once you understand the regression problem, yes, you can start working onto the problem statement. Because if you start today, okay, and in the upcoming days, you can submit your project at the earliest. If you have any doubts, no need to hesitate. You can just ask us. Okay. You can drop your messages in the chat box and you can just uh, drop as in the what Telegram group as well. See, it depends on whatever the project you want, right? So in the earlier stage, I have already told you what kind of project you can do. So I'm not telling you have to do only machine learning projects. You can do any kind of AI project. Okay, this is just an example what I have given, what kind of projects you can just work with. Okay, you can work with AI projects. You can work with machine learning. You can work with deep learning. Yeah, you can use Anaconda Navigator to create your projects. Yes, of course. Yes. If you want to work with machine learning, then you should be having some idea about the Python programming as well. Because Python is one of the easiest language, right? So no need to worry. Like if you want to start learning Python, you can start working with the Python programming. How to choose the project? See, again, I have told like you can visit the Kaggle website. In the Kaggle website, you can search for different kinds of problem statement. Okay, so in today's session, what we are doing, we are working on the regression problem, right? And in tomorrow's session, we're going to work on classification. In classification, I'll show the problem statements. You can tell me like what problem statement we can work for. Okay, based on that, we can just see what other things can be done and how we can just work with the project part. Yeah, shall we start now? Yes, we'll continue now. uh, I know that you have a lot of questions. Again, I'm telling, if you have a lot of questions, what you can just do is we'll be having AMS sessions in coming Friday. You can connect over there and you'll be given a chance to clarify your doubts as well. Okay. Yes. Okay. Now we are just understanding the BMI and the charges again. Let's see how the BMI and the charges is working. Uh, you can see here one specific scenario. Like in the x-axis, there is BMI, which means body mass index. We had told one simple thing that whenever the BMI is like 25 to 30, that I think it is 23 to 26. That is the normal range of BMI, right? So there are few people whose BMI is much higher. You can see that there's a person whose BMI is 53.13, which means he's too fat, and 52.58 also. And you can see the deviation here. Again, as the BMI is crossing more than 30, for the especially for the smokers, there's a high chances of getting the medical charges. Okay. So there are two scenarios here. These people are not maintaining the BMI rate also, and they're not maintaining the habit of smoking as well. So that is the reason they are spending a lot of amount or uh, money for the medical charges or medical expenses annually. Okay. Before we start correlation, I just want a thumbs up from you guys. Like, I just want your point of view. Like, what is correlation? Can anyone tell me what is this correlation? Relationship, yes. Relationship between two variables, good. Yes. Yes, exactly. Correlation means we are just checking like how the columns are related to each other, right? Now I'm gonna show like how the correlation works here. You can see this is how the correlation works here. Now, if the data points form something like this, these are called as perfect positive correlation. This is nothing but the perfect positive correlation. And this is considered as strong positive correlation. There is a correlation, but it is strong, not perfect. Okay, we are telling it as strong positive correlation. Okay, then here we have weak positive correlation. Why it is positive? It is going from lower to the higher. Understand this thing. We have to understand the terms, terminologies, each and everything. Okay, perfectly means like it is forming a perfect line here, right? And strong means like the small interchange is there and it is positive here, and it is weak positive correlation. Here this is no correlation. Okay, and if we take negative correlation, again it follows something like this: negative, weak correlation, strong negative correlation, and perfect negative correlation. Okay, now I'll just show how exactly the correlation value ranges. Now the correlation value ranges from -1 to +1. Okay, now if you just want to check the correlation in pandas, there is a function called CORR. Now if you just use CORR function and if you give the column names, you can get the correlation values. Okay, now what you are giving here from the medical DF, which means from the entire data set, there is a column called charges, and for that charges you are trying to find the correlated value, and you are comparing with the column called age and charges. You are checking the correlation between the two columns here, charges and the age. And let's check. There is 29%, which means 29% it is related, which means approx 30. You can see it is showing 29.9, which means approx 30% it is related. Okay, which means there is one scenario that if the age value is increased, there is a small change in the charges as well. Why? Because it is showing 30%, right? If the age is getting increased, there is a small change in charges also. That is what they are trying to tell. It is correlated. It is related. Okay. Now let us see the BMI as well, whether we are checking whether BMI is related to the charges here. It is showing almost 20%. Even BMI is correlated, somewhat like with the least amount of value. Okay, but it is related. It is showing 20%. It is related. Okay, but you can definitely tell that as the age goes, the medical charges also will be increased. That is what we have some understanding from the data. Now, let me tell you one more thing. Whenever you try to find out the correlation, okay, you should be sure that the columns, the data should be the numbers, not the categorical data, because correlation can be only checked with the numbers, not with the categorical data. The string values cannot be used. Okay. Now, there is a column called smoker where we had a value called no and yes. Now, I just wanted to check the correlation values between smoker and the charges. So that is the string values. I cannot do that. So that is the reason I'm just replacing the values. How I'm replacing, you can see in the column. Let me just show you the, just a second. Yeah, let me just add one cell here so that I can just show it to you. where we went. Yeah, here. Okay. Now, if I just randomly check medical DF here, no, this is the medical data, right? Now, in the medical data, you can see there is a column called smoker, and the smoker has the values called S, no, S, no, S, no, etc. Right? Now, if you just check with the correlation value, it will throw an error. Why? Because it is not the number. So, in that case, what we are trying to do, I'm replacing the value here. Wherever there is a value called no, I'm just replacing it with 0. Wherever there is a value called S, I'm replacing it with a value called 1. Okay, that is clear. And those things I'm storing in the variable called smoker val. Okay, then again, I'm going to use the map function so that it can reflect to the existing values. Then I'm trying out to find out the correlation between charges and smoker number. Now let's see what is the correlation. Now you can see the output it is showing 78.7, which means there is a high correlation, which means we consider it is the strong correlation, strong positive correlation. You can consider this one. Strong positive correlation. Okay, because the value is 78. It is strong positive correlation. Now, as if the person is giving whether the habit of smoking yes or no, directly we can tell that, we can estimate what is the charges he can be bearing. Why? Because smoker plays a really important role in the data set, understanding what is the medical charges a person can bear. Okay. Guys, are you getting the things? Yes. Yes. So in simple terms, you have to make sure, or you have to understand that smoker is one of the major case, okay, where it is giving the medical charges. Okay. Now let us come to the linear regression using single feature. What I'm trying to do here is, okay, so basically I'm just showing how exactly the modeling works. So I'm trying to show a simple scenario here. Okay. Now I'm filtering the entire data. I'm taking only the non-smokers. Okay. So in the entire data, there are two different categories, right? There are people who have the habit of smoking, and there are another set of people, the people who doesn't have the habit of smoking. Okay. Now, to make it more clear, what I'm doing, I'm taking all the people who doesn't have the smoking, who doesn't have the habit of smoking. I'm taking all the non-smokers. To make it more understandable, you can see that I have taken the variable name called non-smoker DF so that you can easily understand what is happening here. And I have written the documentation as well. So that once after the session, if you want to work it again, you can just read down the documentation and understand each and every step. Okay. So no need to worry if you are not getting this. And I have just written the entire documentation as well. Okay. So any doubts, guys? Yeah. Okay. Cool. Cool. Okay. Few people are telling explain it again. I know that for the beginners, it is quite trickier to understand as well because a lot of things it has been involved here. Okay. So I would recommend as we are lagging out of time, again, tomorrow we have the another session where we'll be discussing about the classification. Similar kind of concept will be repeated again over there as well with the different problem statement. Okay. You can get a clarity over there also. And you can also go with the recorded videos just to take a recap and to understand. I believe that if you watch the recording for the people who are not getting, if you watch 2 or 3 times, definitely you will be understanding the stuff. Yes. The main thing is you just have to execute the code line by line and you have to read down the documentation as well. Other recordings are available in the YouTube. Why? Because we are going live on the YouTube as well. You can visit to our channel, EduNet Foundation, and you can just find out the recordings there. Yes. Okay. Now here you can see that I've taken the variable called non-smoker data. Okay, non-smoker DF, where I have filtered out all the people who doesn't have this habit of smoking. Okay, I'll just try to run this. Now here, previously you can see that we had the data like 1338, right? It was the entire medical data. But here I have taken non-smoker data, which means we have only 1064. If you take the column called smoker, in the smoker column, we have only no's here, which means the people who doesn't smoke, their entire data is here. Okay. Now let us try to create a scatter plot and understand this. Now you can see that this is how the scatter plot is being created. There are two specific clusters. Now, if I just create a linear regression, I need to create a best fit line. Now, how I have to create a best fit line? Let me just show you again. Okay. So you have to create a best fit line, something like this. Okay. Sorry. Yeah. Now, if you create best fit line something like this or exactly in between, probably there will be a less error rate. Why? Because there are a lot of data points upwards also. If you create a best fit line here, which means your model is not good, it is high time error rate. Now you can compare all the values. A lot of data points are at the bottom. And if you are evaluating here, the distance is really high. This will become your actual point and this will become your predicted point. The distance for each and every data point would be much higher. But if you create a regression line somewhere here, there'll be a less amount of error rate here. Okay. I'll clear all the drawings now. I'll close this. Yes. Okay. Now, you might be thinking, right, how to create a best fit line. Now, to create a best fit line, we are talking about linear regression. Now, in linear regression, we have a specific formula that is called as y equal to wx plus b. Okay. Now, I'll just tell what is that wx plus b. Now, we are using single feature. That feature is nothing but age column. We are trying to predict. The medical charges based on the age. Single feature. Understand one thing here. We are trying to predict the medical charges based on the people's age. Only one specific variable I'm taking. Only one column I'm taking now. To make you understand, I'm taking only one column here. Based on the age, we are trying to predict the medical charges. Right? Now you can see here, to predict that, we have a formula here. Y equal to wx plus b. Now this b stands for the intercept. In mathematics, you'll come across these things. W stands for your slope. And this x is nothing but your feature. That's nothing but your age value. And what it is this y? This y is nothing but your charges column. What is this y? Y is nothing but your charges. Okay. In simple, if you put the model here, you can see this y is nothing but your charges. W is nothing but your slope. Age is nothing but your x here. B is nothing but your intercept. Okay. Now this, you might be thinking where we can get this slope value and the intercept, right? Okay. To make you more understand, what we are trying to do is, we are randomly giving the slope value and the intercept value just to try out. Okay. I'm not sure what kind of slope value to be given, what kind of intercept value to be given. I'm not aware what is the exact value I have to use it. But to make you understand what I'm doing, I'll just I'll create a function where if I just pass the slope value and intercept value, it will create a regression line. Okay. To do that, I've created a simple Python function where I'm taking the age column. I'm taking the W. W is nothing but your slope. B is nothing but your intercept. This is a simple Python function. No need to worry on this. I have created a simple function so that you can understand, you can implement this task here. Now, what I'm returning? I'm returning this formula. What is this formula? W will be multiplied with age plus it will be added with the intercept. Okay. Here, I'll just create this function now. Now, here you can see I'm passing the W value as 50. Now you might be thinking, right? Why I'm passing the W value as 50? Do you have any idea? No, I don't have any idea. what will be the slope value I need to give for that? I don't have any idea, nor the intercept. I don't have the intercept value also either. Okay. I've given the value as 50 and 100 for the intercept. Okay. Slope is 50, intercept is 100. I'm running this now. Okay. Now I'll just try to execute this. I'll create a chart now. Okay. Now, based on that value 50 and intercept value, okay, intercept value 100, slope value 50, and the original values of the age column, based on that, what I have done, I have created a regression line, which means best fit line. Okay. This is the line what I have created by giving this values. Now, this line, what I need to do is I need to put into the model and I need to check what is the where exactly my best fit line is fitting. Okay. Now you can see that I need to fit the best fit line exactly here, right? Now I have given slope is 50, intercept is 100. I'm not sure where my line is coming. I don't know whether my line is coming at the top, at the bottom or something. To do that, I'll just check it out. Yes. Now, again, I have created another function here where the code has been written with the existing value. I'm just putting those what regression line here, and it is coming at the bottom. Now, can you guys tell me whether my regression line is working perfectly fine? No, right? No. Where exactly I need to put this? I need to put exactly in the between. I need to put this regression line in between so that it can reduce the error rate. Now, what I'll be doing, I'll just create another what Python function so that I can just change the values. Now, this time I have created try parameters function so that I can pass the W value and the B value. W is nothing but the slope value. 500 is the intercept value. Okay. This time I'm passing new values, 100 and 500. Let's try out where exactly our line will come. Now, compared to the previous values, now my line came little upwards, but it's not working fine. Okay. Again, I'm changing the parameters again. I'm passing the value called 40 and 6000 again. Let's try out for this. Again, we are getting somewhere here. I am not sure like how many times I need to put the values, how many times I need to give the values so that I can exactly create a best fit line. This is the manual modeling, what I'm doing. Okay, this is not the machine learning concept, right? I'm giving the manual values. Mathematically, I'm giving the values, but I'm unable to create a best fit line. So what I'll be doing, I'll be using machine learning system now. I'll be using machine learning algorithm so that my machine learning can understand the pattern, and by understanding the pattern, it can create a regression line. Okay. Yes. Now let's see one more concept called loss function or cost function here. Now you might be thinking, what is this loss function, right? Now, loss function is nothing but we are estimating what is the loss we are getting from the model, right? What is the error rate we are getting from the model? There are a lot of loss functions. Okay. We have MSE. MSE means mean squared error. We have RMSE, root mean squared error. MAE we have mean absolute error. Lot of loss functions we have. But in this specific scenarios, we are using RMSE, which means root mean squared error. Clear? Okay. Now, I'll just create a function for to create a RMSE value so that once I pass the value, my model can tell what is the RMSE here. Okay. What is this RMSE? RMSE has certain formula. You can see that predicted value minus actual value whole square divided by n. Okay. Whatever the predictions I have taken, I'm subtracting with the actual value with the whole square divided by n, and upon the whole square root of that. Square root of summation of n predicted minus actual whole square divided by n. So this is nothing but your RMSE, which means root mean squared error. Okay. The same formula, I have done the breakthrough here. I've created a manual Python function. You can see NP of SQRT, which means square root. I'm taking the mean of that. I'm taking again square root of that. subtracting targets minus the predictions. Okay. Now I'm passing the slope value as 50 and 100 as the intercept value. And I'll just run this and I'll just try the parameters here. Yes. Now, here you can see for slope value 50 and 100 intercept value, I'm getting somewhere here, right? I'm not getting a perfect match here, right? I need to create a regression line exactly in between. It's not at all working. Now, what I'll be doing is I'll just create the targets and charges and I'll just try to predict the RMSE here. Now, once I'm predicting the RMSE, your RMSE is giving us 8,461. Now, how can you compute this RMSE here? Now we are getting this RMSE value, right? How can you compute? What can you understand by RMSE? Any idea? Students, can you post your answer response in the chat box? No. Like we have the value, right? We have the RMSE value. We have the RMSE value 8,461. How can you compare this value with the original values? Like it is not the predicted value. No. If you are telling high error, no correlation. No. Okay. Let me make it more simple. Okay. So basically, let me just create a code cell here to make you understand here. Okay, again I need to. Okay, I'll just write it here. Now, if you just check the medical df dot head. Okay. Now you can see that I'm getting the medical entire medical charges data set, right? And here we are having the value called charges. And in the charges column, you can see that the actual value is 16,884, right? The actual charges is nothing but 16,884. And we are getting the RMSE value as 8,461. Now, we are getting a conclusion that for this actual value 16,884, we are off by 8,461. Which means it is telling if you just subtract 8,461 from this actual value, what will be the charges your model is predicting? Somewhere around 8,461 something, right? And if you just take this value, what 1725, and we are off by 8,461. So it will go something negative value. Now your model is giving the off value of 8,461. If your model is predicting 30,000, you are off by 8,461, which means approx your model is predicting 21,000 something. Okay. Why your model is giving, why your RMSE value is giving this much? Because your slope and your intercept is not fitting proper. If your slope and intercept is fitting really properly, your RMSE value will be decreased. Now you have to understand one thing here. Lower the RMSE, the better the model will be. You have to make sure that RMSE value should be really lowered down. You have to reduce the RMSE value. Okay. If you are getting the RMSE value like 2000, 1500, yes, it's really good model because your RMSE value is like 1500, and if your actual value is 16,800, your model is giving off of 1500 or something, which is fair enough, which is totally acceptable into the real-time scenario. Okay. So students, have you understood the intuition behind the RMSE? Post your message in the chat box. Is it clear? Yes. Good. Are you feeling interesting? Be honest. Is the problem statement is interesting? Yes. Okay. Okay. So even I recommend that after the session, you can just go ahead with understanding the things and stuff. Okay. You have to be sure that if you want to create the project, uh, don't forget to manually practice it out. Okay. After the session, I'll be sharing all the links. I'll be giving the GitHub links. I'll be sharing the project details. You can just start working on the stuff. Okay. Yes. Okay. Again, I'll just quick revise what is this RMSE. RMSE is nothing but you are taking out the loss function. Previously, I told that from the actual value to the predicted data, there is a distance, right? That's nothing but your RMSE is. Okay. Which is called as root mean squared error. And if the actual value is 20,000 and if your RMSE is 5,000, you have to uh, remove 5,000 from the actual value. If the actual value is 20,000, your model is predicting something like 15,000. Okay. That is how the RMSE goes. Yes. Okay. This is the same function we tried for slope value 50 and intercept value 100. Okay. And you can see in the same picture, you can get entire thing. Okay. You have the entire data points here, and we have created a best fit line, which is not fitting properly with the RMSE value of 8,461. Okay. Which is not at all good. Okay. I need to put a regression line exactly between. So for that case, what I'll be doing is I'll just use linear regression algorithm. Now, previously I have told linear regression. If you want to use the linear regression model, okay, in the machine learning, I believe in this slide I have shown you, okay. It uses the formula to understand the pattern and it will create a best fit line, something like this, right? Now, here you'll be using the library called sklearn. Now, sklearn is the library where you can get the linear regression algorithm. Okay. From the sklearn.linear model, you are using the linear model here and you have to import the linear regression. Once you import the linear regression what algorithm, what you have to do? You have to create a variable and you have to initialize the linear regression object here. Right? You have imported the linear regression algorithm, right? You have to use that linear regression algorithm. So you'll just create a variable called model and you'll tell that that model is nothing but your linear regression is. Okay. I'll just run this. Now, what is your model? Your model is nothing but your linear regression. You can cross check here. You can just check what is this model. Sorry, my mistake. If you just check what is this model, your model is nothing but it is linear regression. This is your model, what you have created now. Okay. Now for this model, for this linear regression model, this is the AI model. You'll just put all the data into this linear regression. How you will put? You will separate the values now. You will take two different variables, inputs and targets. Now, what is this inputs? Input is nothing but your age column. Targets is nothing but the column what you are trying to predict. Don't get confused here. Input is nothing but the age column, the feature basically. Target is nothing but the column what you are trying to predict. You are trying to predict the charges column and you are giving the age column. You are giving only the age and you are giving the column called charges and giving your model to split the data here. And it is telling that there's only one column in the input and only one column in the target as well. And it has 1064 values. So whenever you train the model, you should be sure that input and the target size should be same for the training purpose. Now, how you will train the model now? We'll just use model. You're training the model here. Okay. You're using model. Your model is nothing but linear regression and fit. You're using dot fit method. You're trying to fit the data. And what you are trying to fit? You are fitting the inputs and the target. Now, don't get confused. What is this inputs and targets? Your inputs is nothing but from the non-smoker data, you have taken out the age column. And from the non-smoker data, you have taken the charges column. That's nothing but your targets. Okay. Now, before going to the exam, okay, you'll revise all your textbooks, right? You'll see what is the question and you will see the solution for that. So similar to that, I'm giving all the data for the machine so that it can understand the question and it can understand the solution also. It is getting trained. Your model is getting trained. Now you'll just run this. Now here, your model has been trained on the data what you have given to that. Okay. Now once it is been trained, now what you'll be doing, you'll try to take out the prediction now. How you will take the prediction? You'll just use model. Basically means your model has got trained now, right? With the linear regression algorithm. Now what you'll do, you'll just use model.predict. Now you're trying to predict. Now how you're trying to predict, you are giving the numpy array here, array value. Now you're predicting what is the medical charges for the age 23, what is the medical charges for the age 37, what is the charges for 61. And again, I'm giving a clarity here. I'm not telling that you have to use the same values. You can change the values. Let me just give the value called 60 here. Okay. Here, let me just give the value called 50. You can just change up the values and you can predict it out. Now, once you give the values and if you try to run here, now your model is giving that for the age 23, this is the medical charges, that is 4,055. And for the age 50, this is the medical charges, 11,271. And for the age 60, this is the medical charges, that is 13,942. So this is for the single variable. Understand? We have created a machine learning model only for single variable, only for the age column. Guys, have you understood? Students, is it clear? Is it understandable? Yes. I'm happy that a lot of people are getting S. Okay. And people who are finding it little difficult, who are fresh to this concept, I would recommend you can just read down the documentation again, practice it for 2 or thrice. Yes, you will be able to create a machine learning project anytime. Yes. Okay. Now, if you just check the variable called inputs here, see, this is the variable what we have created. In inputs, you have the entire age values, 18, 28, 33, 32, etc. Almost 1064 values are there. And now what you'll do, you'll just use model.predict. What is this model? Your linear regression model, right? And you're trying to predict this inputs. For those ages, for these ages, you are predicting the medical charges. Now you can see that there's an age called 18 here. For the 18 value, the prediction is 2,719. Age 28, medical charges is 5,391. Like that, it follows. Okay. And what is the RMSE for that? RMSE is nothing but 4,662. For this specific data, what is the RMSE we are getting? 4,662. And for our linear regression algorithm, if you want to check what is the coefficient and what is the intercept they have taken, you can just use model.intercept, where you can get the intercept value, that is minus 2091. And what is the coefficient? Coefficient is 261. Manually, if you remember here, we gave the value, right? Here I have to replace 261 and minus 2061 or something. Here. These values, if I just place it over there, it will create a line again. Okay. Now you can see this is how the machine learning flow will work. Again, let me just show you. We'll give the input to the model. Model will give the output again. The predicted value will check with the loss function. You have to optimize again. You have to put again to the model. Again, the model will give the output for you. Now, we have understood one scenario. What is that scenario? That if I just pass the age value, single age value, we are getting the loss function of 4,000 What was the loss function here? 4,662, right? We had used only one single feature, only age column. But now let's try to use with multiple feature. Okay. Now here you can see here I'm using multiple features. Okay. So here I can just replace with non-smoker of age. I can just use again few more columns. Can you just let me know what are other columns what we had learned? I want your comments in the chat box. What are the other columns what we had discussed? Yes, BMI. Apart from that, gender, smoker. Yes, those columns can be implemented here again. Okay, so I think I have created a cell at the bottom. Let me just see here instead of giving here. Okay, yes, here. Okay, so I have given the age, I have given the BMI column, I have given the children column. Previously, I just took only one specific column, right? I just checked age and I've just checked the charges. With the help of age, with the independent variable age, I was just evaluating the charges, right? So this time I'm using three features. I'm giving the model stating that I have the age, BMI, and children, and based on that, predict the medical charges. Okay, entire function is there, and finally it will print me the loss function. Let's see now. Now, compared to the previous example, when I increase the features here, BMI and children, you can see there is a decrease in the loss function, which means the RMSE function. Previously, we had the RMSE value of 4,661 something. Yeah, here. 4,662. That was the loss what we were getting from the previous example with a single feature. But once I'm increasing the features, once I'm increasing the columns, you can see your model is learning much better. And there is a decrease in the loss function, which means our model is working much better, right? Yes. Again, let's do one more thing. Like there is another column. Let's check out the correlation value and scatter plot it and all. What I'll be doing is here. From the non-smoker data, again, I'm checking the correlation of the children. You can see for the children column, there is a correlation of only 13. So there is not much impact having the children column and keeping on it. Okay. So I would rather recommend going with other extra columns here. Okay. So let's see what other columns we can just go for. We'll just check with this. We have included age, BMI, and children. We are getting the loss of 4,608. Here again, see, now there is a change here. Now you might be aware that previously we had used non-smoker data, right? Non-smoker data means the people who were not having the habit of smoking. Now, after that, I have taken the medical data here, the entire medical data. So entire medical data is different and non-smoker data is different. Here, there are smokers as well and non-smokers as well. And here we have only non-smokers. Now, if you have seen the ADA, you might have observed that in the non-smoker data, the maximum medical charges of the person was approx like 33,000, 31,000, etc. Right? But the people who had the habit of smoking, their medical charges was like 61,000, 63,000. Okay. To make it more simple, I'll just show you here. Medical DF, right? This is the entire medical DF. In the entire medical DF, we have total 1,338 entries, which means we are including both smokers as well and non-smokers as well. And if I just check another variable that is non-smoker DF here, here we have 1,064 rows, which means we have the data of only non-smokers. Okay. Now you should be sure like what exact RMSE you are using for and why exactly you are using for. Okay, whether you are using for the entire data or for specific filtered data, you should be careful by using that. Okay, now there's one more technique. There are few more columns, right? So if you just look at the column called smoker, smoker is basically having value called S and no. Okay, so this is non-smoker, right? So I'll just show the medical DF here. Okay, this is medical DF. Smoker value is having S and no. Now, basically, in machine learning, what happens is I cannot directly give the categorical data to the model. I need to convert into the numbers, right? So how can I just convert into the numbers? There are few techniques here. Okay, so we call it as encoding. Okay, so a lot of encoding techniques are there. Okay, so I'll explain two kind of techniques now, and in tomorrow's session again, in while working on classification again, we can discuss other techniques as well. Okay, one is binary encoding. Binary means like with two different values, we had no and yes, right? We are converting no into 0, yes into 1. Okay, so that is nothing but binary encoding. Apart from that, we have one more encoding technique that is called as one hot encoding that we're going to discuss. Okay, first we'll see this. I will just check what is the uh, what count of the smokers as the non-smokers here. The people who doesn't have the habit of smoking, their count is going beyond their medical charges is going like approx 30 or something. Sorry, basically this is a count. And for non-smokers, you can see the count is like we can expect like what 500 something or something. Let me just convert into the numbers now. Okay, so I'm taking a variable called smoker codes, and in the smoker codes, I'm just replacing the values wherever there is a value called 0. Sorry, wherever there is a value called no, I'm replacing it with the value called 0. And wherever there is a value called S, I'm replacing it with the value called 1. Okay. And what I'm doing, I'm just applying a map function so that it can reflect into the data set here. Now you can see that the new column got created that is called as smoker code. And wherever we had a value called S, it's been added with a value called 1. And wherever we had a value called no, it's been updated as 0. Right? Now we have created one more extra feature that is called as smoker code, and now we don't require the smoker column anymore because we have created alternative column or the feature now. Now let's check the correlation, how it is related to the charges now. So upon checking the smoker code column followed with the charges column, it is telling that it is having a strong positive correlation here, right? So it is showing 78%, right? Which is having the positive correlation, and it may have a high impact onto the data set here. Now let's try implementing the algorithm here. Now previously you can see that I had used only age column, BMI, children, and for the target I was giving the column called charges. But this time I have encoded the values. I have applied the binary encoding here, and I have created a column called smoker code. Now I'm implementing the linear regression algorithm here, and I'm fitting the model, and I'm predicting the model, and I'm just taking out the loss function. Now if I just run this, now here you can see by giving a specific column called smoker code, now you can see that how the loss function has been decreased, right? So that was the reason it was giving strong positive correlation. Now smoker code is really important feature in the data set. It's really highly correlated, and it is strong positive correlated with the charges column, and it is playing a important role. Now you can see that if you are passing the age, BMI, children, smoker, your RMSE has been lowered here, which means 6056. Now here you can take a example. What is the example? If your model sorry, if your actual value is like 50,000, okay, if the medical charges of a person is 50,000 and if your RMS is 6,056, you're off by that value, which means your model is predicting approx 54,000 something, which is fair enough, right? We are dropped about almost 50%. Now you can see previously what was the RMSE value? We had a RMSE value of 11,355, right? From the 11,355, you can see like after putting the column called smoker code, however, loss function got reduced to 6,056. Okay. Now there is one more feature what we have not added into this. The feature was the region column again. Okay. We can also try to put that again. Again, we can also do it for the gender column as well. Let me just run this. Okay. I've created another column called sex code now for the gender, but because we had the gender column, male or female, right? So instead, I'm giving the numerical values now, binary encoding over there. And there's not much impact onto the gender column here. You can see it is showing only 0.05. Okay. But even though if I just check with the linear regression, again, it is showing the loss function as 6,056, which is similar to the old readings only with the RMSE value, right? So here I have added sex code, which is not having that much impact. Okay. Then we had one more encoding technique, which is also called as one-hot encoding. Now I'll show you how exactly that one-hot encoding works. Okay. Now imagine that you have a column here where you have the values like cat A, cat B, cat C or something. Let's believe that this is what cat A is nothing but Australia, B is Bangladesh, and C is stand for the China. Okay. So it based on the values, it's gonna try to create the new columns. Okay. The new columns would be created. For an example, Australia column would be created, Bangladesh column would be created in the data set, and the China column also will be created out. Okay. Now, in the data set, if there is a value called cat A, okay, it will search for the China column and it will give the value as 1. And for Bangladesh, sorry, for Australia, it will give the value as 1 because it is cat A. For Australia, it is 1. For Bangladesh, it will give 0. And for China also, it will give 0. Okay. And in the second entry, if the value is cat B, it will search for cat B for the Bangladesh. For Bangladesh, it will give 1. For Australia, it will be 0. And for China, it will be 0. So that is how the one-hot encoding will work. Okay. So students, any doubts still here? Is everything clear till here? Any doubts? Yes. Okay. I'll just take another couple of minutes, okay, and I'll try to wrap it down as quickly as possible. Okay. So just give me 10 more minutes so that we can just wrap the things up. Okay. Okay. Now to use one-hot encoding, what we will be doing is I'll be using the scikit-learn library again, and I'll be using the pre-processing technique. And in that pre-processing technique, I'll be using the function called one-hot encoder. Okay. But because I need to apply the one-hot encoding technique, right? So I'll be using one-hot encoder here. And again, those entire thing I'll be storing in a variable called encode. Okay. Now what I'll be doing is encode basically means it's your one-hot encoder, and I'll try to fit the entire medical data. And there is a specific column called region. Okay. So I'm just trying to fit that. Once I do that, you can see this is how it will be transformed for you. Okay. So the first value was specific. I believe it was Southwest. Okay. For Southwest, it is giving as 1. And for Northeast, Northwest, Southeast, it is giving 0. So that is how the one-hot encoding will work. Okay. Now, if you just apply the one hot function for this, for the entire data, now you can see this is how your data set would look like. Okay. Now you don't require the column called region. Why? Because we have applied the one hot encoding technique for that. Smoker also, it doesn't matter because we have applied the binary encoding for that. And one more column called gender. Okay. For gender also, we have we have created a new column called sex code where we have replaced with zeros and ones, right? So you can select the columns, what you want to give it for the training, and you can just take out the predictions now easily. Okay. Now here we go. Now you can see that I'm using the inputs, targets, and the entire medical data here. Okay. And in the entire medical data, I'm skipping few columns, that is smoker, region, etc., because that is categorical data, and I've converted into the numbers. Here I have given sex code, which has been replaced with the gender, smoker code with the habit of smoking. Then again, the region, northeast, northwest, southeast, southwest. And finally, this is the target column. That's nothing but your medical charges. This is the column what you are trying to predict, right? Now, based on this data, now let us try to see what is the RMSE we are getting. Now we are getting the RMSE of 6041. And now remember one thing, this RMSE, what we are getting is for the entire data set. It's not only for non-smokers. It is for the both smokers as well as the non-smokers. So in the smokers, we had the value like 63,000, 64,000 also, right? There were a few people who have paid the medical charges for 64,000. And if you are taking the 6,000 away from that, probably it will range around 58,000, 59,000, which means our model is becoming much better, which is also acceptable by the companies also, right? So that is how you can just create a machine learning model by using the linear regression. I hope everyone have understood how exactly this machine learning model works, right? Is it clear for everyone? Yes. Any doubts from your end? No doubts, right? Everything is clear. Yes. Cool. Okay. So what we can just do is, okay, the rest of the things we can just keep it for tomorrow's session. Okay. So I'll just utilize only couple of slides again. Okay. I'll show how exactly other models also can be used for your reference purpose. Just a minute. Okay. Okay. I'll just show one more model here. Likewise, how we have used linear regression, right? So similar kind of thing, we can just use one more algorithm called as random forest regressor. Okay. I'll just show how exactly that works. Okay. So you just have to use the similar way. Okay. So you just have to use from scale learn dot. So it is the ensemble technique. Okay. So random forest is one of the ensemble technique. So I'll be using that model here. From sklearn.ensemble, I'll use import random forest regressor. Okay. Okay. Now you can see that I have imported random forest regressor here. Now I'll just define a model here. I'll just use model RF. Now this model RF is nothing but your random forest model, what I'm trying to create here. Okay. So I'll just initialize this model here, random forest regressor. Okay. Now entire thing again is the same. Okay, I'll just copy the entire stuff here. Okay. Wait. Here only I'll just try to replace model RF. Here instead of linear regression, I'll just replace it with the random forest regressor. That's it. Now, once you try to run this, okay, so even random forest regress, sorry, my mistake. Here model random forest regressor. Here I have to just use model RF. See, you have to remember one thing, whatever the model names you are creating, you should be, using that model names here, because I have used the variable called model RF as the variable name. For the prediction also, you have to use model RF only. Okay.
Tawfiq sir, Kartika here.
Yes, ma'am.
Yes. So actually, I can see the students are leaving. So we have an important update, students, to discuss about the LMS. Okay, you all need to do something to submit your achievements. So I will be telling you that right after this. Okay, so stay back. That's very important to do. All of you need to do that. So stay back.
Just for, yeah. Thank you, ma'am. It's just 2 minutes. Like we have almost done with the process. Yeah, with the project part. You can just take a lead after that. Okay. So students, you can just have a look, like our linear regression algorithm gave the RMSE value of 6041. And once I just used random forest regressor, you can just see the improvement here, like how random forest is working much better. It is giving 1825 as the RMSE value. So this random forest algorithm is also considered as one of the powerful algorithm among the machine learning. Okay. So that is how you can just create your machine learning model. Any doubts still here? Yes. I believe that you have enjoyed the session, and it was a really nice topic, I believe. Yes. Any doubts? Yes. So Kartika ma'am, you can just take a lead now.
Sure, sir. Thank you so much. If I can share my screen. Yes. So first thing being, students, you can mark your attendance later, but now stay focused. Okay. I'm going to show you something which most of you must have done it already. But this is to inform you all there is this new update on your LMS. Okay. Some of you found that you're submitting some random achievement screenshots in the achievement section, but now we have mandated this step. Okay. So I hope my screen is visible to everyone, isn't it? If it is a yes, you can send me yes. Okay. So this is how your LMS looks like, correct? So you all must have completed the courses under the advanced section. Yes. So now you have access to the basics and intermediate courses also. You can start doing them as well, but it is compulsory to complete all those courses under advanced. Basic and intermediate, though you can, you can explore them, but completing these 6 courses under each of these courses, you have 3 modules, 5, 2. So accordingly, you have different modules as well. So you have to complete all these courses, and mainly for example, I'm showing you. I have completed this course. Okay, how I'm getting this tag? Because you know the procedure. Once I'm done with all the units, I have to take a screenshot of the achievement page and I have to come here. I have to upload the screenshot here. So this is what we usually do. Correct? But now you can go to your completed courses. Okay, you can click on this view, upload or achievement credentials. Now you have 2 options. One is to choose your file, that is your achievement screenshot, you can upload it. 2, you can paste a link of this. Now you can ask me, ma'am, what is this link? Where do I get this? So this is very simple. You can just click on this view course of any completed courses you have, right? You can click here Click on complete module. Or even if it is showing you next also, that is fine. You can redo it. There is no harm in doing that. Okay, which is a very simple course. And so while you come to this page, usually we take a screenshot of this page, right? But now I would want you to click on this link symbol. Let me zoom in a bit. So you can see this copy link symbol, right? I would want all of you to click on this link. Okay. So it won't be copied just like that. Just click on this link and then you will be seeing this pop-up saying Achievement Explore AI Basics. Explore AI Basics is the name of the course. Okay. Just click on this copy link symbol and you will be able to see this pop-up. Now click on this arrow symbol. Click on this arrow symbol. This is to copy your URL. Okay. Now you can see that the URL is copied. It is very simple. On the same achievement page, you can click on this copy URL symbol, then click on this arrow mark. Your URL is copied now. Now, what is the next step? Open a new tab and paste this link in there. Paste this link in there, in a new tab. Okay, once this tab is open, you will be able to see your achievement like this. Can you see Kartika? Yes, that is my name. Similarly, you will be able to see your name in that place. Now, which is your achievement? This is your achievement page. You need to take a screenshot of this page and you have to upload it going back to this page. Okay, going back to the completed course, clicking on this symbol, clicking on this green option. Now I have to save this screenshot. I'm screenshotting this. Okay, I am saving it. Okay, where is my screenshot? Right, no problem. I'm taking it again. Right, I'm taking a screenshot of this page. I'm now considering this as my achievement certificate. I don't know where my screenshot is going, but no problem. Already I have one. So I'm clicking on this choose file option. I have my achievement screenshot already. I am got the Zoom screen. Right. I have uploaded the achievement screenshot here with my name. Now, the previous achievement, that will also work. But the main thing is like you can use this where you have your name and the date of completion as well. This will be more credible. Okay. So in this place, you can achieve your achievement screenshot, this new page with your name and your date of completion. Just select that and click on open. It will be open. Now for the link, I have this link already from the place where I have copied this. Okay. Paste the link and submit it. So if you have completed 6 courses, do the same for all 6 courses, which doesn't mean that you have to redo all those 6 courses. It is just, again, I have completed this course also. I'm clicking on view course option and I have completed everything. Okay. And I'm going to the last page. Now, so you know how to click on this next option, right? So just do that. You will get to see your achievement page and copy the URL just like I've done here. Copy link, click on this arrow symbol. Now your URL is copied. Open a new tab, paste it there. It will take you to the achievement page. Take a screenshot of the page where you can see your name and the date of completion also. Take a screenshot of that, save it with a course name or anything like that and upload it here. Okay, going back here, you upload this thing, certificate or credentials. Then you can choose file, attach your screenshot, and here you can paste the link of the same. Okay, and then submit it. So this is the new update that you all need to do. Was that clear, everybody? If it is a yes, you can send me yes. This will add more credibility to your certificate. So that is the reason why we are telling you to follow this. Is it all clear, all of you?
And
I would want confirmation on the YouTube as well. So pasting link is compulsory now. Yes, Anjali ma'am.
going forward, students, you have to paste the link only. You don't have to paste the screenshot and the link. Use one method only. You have to paste the link. And remember, you have to only paste the link. Please do not ask the question if you have to do the both. No, you have to paste the link. If you have already completed the courses, that is good. But going forward, you have to use the one method. You have to paste the link only. Paste the link. Links are mandatory, yes, because at the backend, we will be verifying who has completed the courses and who not. So please, you have to use the link only. Thanks.
Sure. So pasting link is now compulsory. You know how to do it, right, students? So please go ahead and do that for all those completed courses of yours. I would like to get some confirmation on the YouTube as well. So later this session, we will be sharing the recording for the same. You can follow the steps in case you missed it now and do that. Okay. So tomorrow also we have our technical session. We'll be sending the reminders in the Telegram group. Please do join that. Okay. And meanwhile, please log into your LMS, mark your attendance. Attendance link is also shared in here. Once again, I'm sharing it. Okay. So please do mark them. And sometimes some students are saying it's not working. Of course, while a bunch of students are accessing LMS at the same time for the same purpose, sometimes it may take some time. It loads, it buffers, it happens. But you can try later. Okay, which doesn't mean that the portal is locked or closed. Nothing like that. It is a temporary delay. I'm pasting the link in the YouTube live as well, and I'm pasting it here as well. Thank you all so much. We will be sharing the further details on your Telegram group. So stay tuned in there. Thank you all so much.